We're on 6.1 notes measurement of angles. Okay. An angle is said to be in standard position if, so if you look here at our picture, if the starting side, well, if the vertex goes through the origin, yeah, we'll pretend that there's a big giant thing that goes through origin. Its initial side starts on the positive x-axis, and you're going to go counterclockwise. And where it stops, that is its terminal side. So this is an angle. It's an unknown measurement. To represent an unknown measurement, we use a symbol called theta. It's like a 0 with a hat on top, or an O with a hat on top. And this guy is called theta. Okay? Theta represents an unknown angle measurement. Theta. Okay? So if I say find theta, that's like me asking you to find the x of something. All right, so yeah. An unknown angle measure. All right, counterclock rotation. Okay. We go counterclockwise when we're using a coordinate plane to graph and find angles. All right. If it's positive. Now, the only time we go clockwise is if it is what? Negative. Okay. So we go clockwise, meaning we're going to go this way if it is a negative theta. All right. The other Greek letters that you may see are besides theta. So this is what theta looks like, drawn better than what Miss Jones does. Theta, beta, and sigma. Okay. Say it with me. Theta, beta, sigma. Say it again. Theta, beta, sigma. It's just 3 letters. Theta, beta, sigma.
If you go, voice I, what is actually supposed to be to that?
It's like a 0 with a line.
Yeah, you could just said that.
The line turns.
I know mine has a little flair to it.
Oh, it has something.
Okay. All right. Now, the amount of rotation can be measured in degrees or radians. Okay. We all know about degrees, right? All right. We're going to be learning about radians. Okay. What is a radian? Okay. So a radian measure of an angle. So example, we have angle AOB because in geometry, we learned that to name an angle, you have your endpoints, your middle angle, well, your middle, what is that called? Intersection? Yeah. The intersection of the 2 rays. I'm not a geometry teacher, but I got this. The intersection of the 2 rays. Okay. In this case, it's your R, right? Your radius. All right. So angle AOB. We do not know its measure. So guess what we have here? Theta, because we don't know the measure, right? We do not know the measure of that. So it's theta. Now, to find the measure of theta, we find it by taking the arc length, which is S. So S is our arc length. And dividing by R, our radius. That's going to tell us our angle measure in radians. Not in degrees, but in radians. Okay, so let's apply some numbers to this. All right. So flip over. It's a little booklet, by the way, in case you haven't figured that out. Your notes are. Okay, so we're going to look here at this circle. Again, the values, the lines got a little wonky, but I'm just going to draw a big old circle. It's going to act like they're connected. All right, it wants to know what is the measure of this unknown angle, right? And again, on the front, we wrote that theta equals S divided by R, right? Okay, well, what is our S? What is our R? So our angle measure is 5/2 radians. So if I'm giving the arc length and the radius, I can tell you the arc length. I mean, I can tell you my radians, right? So if I have the arc length and the radius, I can tell you what theta is. Yes, do we see that? Okay, now, example 2 is to show us how just what the value of 1 theta is. So 1 theta is if the value of the arc length is the same as the value of your radius. That's because you would have R divided by R, which equals 1. Because anything divided by itself is 1. So we have 1 radian equals the measure of a central angle whose arc length has the length r. So this is key to understanding because when we're working with what's called a unit circle, the radius is just a unit, and we're working our way around that circle. All right. So talking about going around a circle, what is it called when you find out around the circle? The circumference. Perfect. And how do you find the circumference of a circle?
Radius squared times pi or diameter times pi.
It's the diameter times pi. Not radius squared, that is area.
That's area, that's right.
Okay, diameter times pi, or you can write it as 2 pi r.
That's what it was.
Okay, and that's going to tell us. So when we go around a circle, that means that your arc length equals 2 pi r, right? Does that make sense? Because we went all the way around. So when I'm trying to find 1 revolution, well, we know it's 360 degrees equals, well, my arc length was 2 pi r. What happens to the r's?
They cancel.
They cancel. So now we know that 360 degrees equals 2 pi radians. Okay. As long as there's a pi there, writing radians isn't always necessary. Not always necessary. It's a good practice, but it's not always necessary, okay? So from here on out, if I'm not going full 360, to figure out how many radians, we would set up a proportion, right? Do you guys remember cross multiplying and dividing? Some of your teachers may have called it the butterfly, right? Well, instead of having to do that over and over, there's just formulas that we follow, okay? So if I'm going from degrees to radians, how do I go from a degree to a radian? I'm going to take that degree measure. So whatever the degree is, and multiply by pi over 180 degrees. Okay? And I want to make sure that I leave in terms of pi. Okay? What it means to leave in terms of pi is that when you are simplifying and reducing, you do not worry about the pi. You just worry about the numbers. Yes.
What is in the denominator?
180 degrees.
Oh, okay.
It got a little crazy. Okay. So that's going degrees to radians. Now, if we want to go radians to degrees, it's going to be the radians, but instead of pi over 180, we're going to multiply by the reciprocal of that. So we're going to multiply by 180 degrees over pi. Okay, the reason why you're doing both of them is that in degrees, we're trying to cancel out the degree units. In radians, we're trying to cancel out the radian units. All right, and if it's not stated, we're typically going to round to 2 decimal places. All right, are we ready to practice using the formulas? All right, we're going to do the odds together, and then you're going to do the evens, and we'll check back, okay? So we're going to do 3 and 5 together, and then you're going to do 4 and 6. All right? So we're going to start with 3. 3, we're going to convert negative 225 degrees to radians. So to convert negative 225 degrees, I'm following the degrees to radian rule, right? So it says I'm going to multiply negative 225 times pi over 180. My 8s are doing weird things today. I don't know why. Okay. When you're multiplying, you multiply straight across, right? Numerator times numerator, denominator times denominator. Agree? So we have negative 225 times pi over 180. You always want to make sure that it's in the simplest form. If you're not good at reducing fractions, you can use the calculator to help you reduce, okay? So Now, there'll be times where you don't have a calculator, so you're going to need to practice on those reducing skills. So we're in the calculator, we're putting negative 225 divided by 180. Notice that it's going to give me a what? A decimal. On our calculator, to go from a decimal to a fraction, I'm going to press math, and you see where it says froc?
Oh,
And you're going to press 1, enter. So we pressed math 1, enter, and what did it do to my decimal? It turned it into a fraction. I'll have to look and see what you did. That would be a user error. So it equals negative 5/4, and then you put the pi. This lets us know that this is in radians. If you want to like be extra, you can write rad at the end also. Okay, so that's going from a degree to a radian. Now we're going to go from a radian to a degree, following the second formula. So on 5, we're doing together. We have negative pi divided by 3, and we're multiplying it times 180 over pi. Times 180 over pi. Okay, what do you notice that happens automatically here? The pi's cancel out. I multiply straight across, and I'm left with negative 180 divided by 3. Well, what is negative 180 divided by 3?
Negative 60.
Negative 60, and it's going to be degrees because I went from radians to degrees. You either can put the degree symbol or write DEG. Okay. All right. I'm going to give you guys a moment to do 4 and 6. Okay. As you finish 4 and 6, check with your peers. If you need help, that is what I am here for. Okay. I'm coming. All right, let's check ourselves. All right, on 4, let's do 4. Can we do 4? All right, so 4, we have 50 over 1 times pi over 180. Did anyone notice that you can just cancel out your zeros?
Oh,
So we had 5 pi over 18. Yeah, how'd we do?
Good.
Got it? Okay. Boom, bam. Now we have 3 pi over 4. So we have 3 pi over 4 times 180 over pi. What happens? Pi's cancel. If you want to get a head start on things and I can't talk. If you wanted to get a head start, could I have divided 180 by 4? Yeah, technically I could. So if I wanted to try to do it without a calculator, I could do 4 divided by 180 is going to be, anyone else?
45.
45, and then multiply. Now I'm just left with 3 times 45. And what did we get? 135.
Okay.
Okay. Yes. Doable? All right. Step 1. We did it. We don't want to count them all.
Oh.
All right. Here we go. If the terminal side of an angle lies along an axis, this angle is called a quadrantal angle. Okay, so we're going to go through and talk about our quadrantal angles. Okay, your quadrantal angles are what lie on your positive x, your negative x, your positive y, and your negative y. Okay. So in degrees, our first quadrantal angle is 0 degrees. Let's take it back to geometry. What does this mean?
Right angle.
A right angle, which is 90 degrees. So on our positive y-axis, that's our 90-degree angle. If I go another 90 degrees, where am I going to be at? 180 degrees. If I go another 90 degrees, where am I going to be at? 270 degrees. And if I go another 90 degrees, 360 degrees. Okay. So in quadrant 1, you have angles between 0 and 90. Do we see that? In quadrant 2, we have angles between 90 and 180. In quadrant 3, we have angles between 180 and in quadrant 4, we have angles between 360. Yes? Is that doable? All right, now we're going to go clockwise. When we're going clockwise, those are going to be their negative values, right? So clockwise, instead of this being 360, this is 0 degrees. Instead of this being 270, it is negative 90 degrees. Instead of this being positive 180, it's now going to be negative 180. Instead of being 90 degrees, this is going to be negative 270. And then we come back at negative 360. And that's because when we have a negative, that means we go clockwise instead of counterclockwise. Are we okay? All right. So these are our degrees. Now we're going to do the same thing, but we're going to do it in radian measurement. Okay? Radian measurement is saying that we've already discussed that 360 degrees equals 2 pi, right? So radian measurement is saying that we're taking 2 pi and we're splitting it into 4 pieces. Okay? So we're taking 2 pi and splitting it into 4 pieces. So we're going to start here at 0 radians. So this is going to be pi over 2. This would be a whole pi, 1 pi. This is going to be 3 pi over 2. And then we're going to have our whole 2 pi. So each quadrant is half of a pi. Do we see that? What? The clock? You don't say. Okay. So in quadrant 1, my radian value is between 0 and pi over 2. So anything between 0 and a half is going to be in quadrant 1. Anything between a half and 1 are going to be in quadrant 2. Anything between 1 and a half 1 and 1.5 is gonna be in quadrant 3, and anything between 1.5 and 2 is gonna be in quadrant 4. So those are our positives. Now we gotta do our negatives. So we have 0 pi, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. The red is when we have a negative and we have to go clockwise. All right, let's sketch. Let's make sure we understand where angles will fall, okay? So on 8, if I have 120 degrees, so I'm going to draw my, what quadrant should 120 degrees fall in?
What's it, 3?
120?
Sorry, 2.
So we know that our terminal side has to be in quadrant 2. So we start here at 0. We know that this is 90, and how far from 90 do we need to go to get to 120? 30, so like a third of the way, right? So this would be our sketch of 120 degrees. Terrible? Not the worst. Okay, let's do the negative 45. So looking at our graph, our grid, where would what quadrant should negative 45 fall in? Four. So it should fall in quadrant 4. And that's because we're going from 0 to negative 90. So between 0 and negative 90, where would negative 45 fall? Smack dab in the middle. Good job. So we started here and we end here. And that's our negative 45 degrees. Okay. All right. So if you're feeling confident, you need something to do this weekend, you can start on the on your converting skills.
Hey, can you go back?
Yes, I can.